You are listening to The Vocal Technologist. Spoken tech for your ears.
Imagine a scenario where your most productive coworker is a piece of software.
Right.
And it literally takes control of your mouse.
Just physically moves the cursor around the screen.
Exactly.
Yeah.
It takes over the mouse, maxes out the company credit card on compute tokens, and never once asks for a coffee break.
Which sounds completely absurd.
It does. I mean, it sounds like science fiction, but it is actually happening on devices all over the world. As the vocal technologist, I spend my life looking under the hood of emerging systems.
Yeah.
I really want to figure out where the code actually meets the real world, and we have got a massive stack of research articles and internal memos to unpack.
Heaps of data to get through.
Spot on. The goal here is to explore a monumental transition happening in the tech sector. We are moving from a simple chat interface, that kind of just answers your questions, to a fully autonomous digital employee that actually does your job.
It really is a fundamental rewiring of how work gets done. You are no longer just asking a machine a question and passively waiting for an answer. You are giving a machine a budget, a specific goal, and the actual authority to execute tasks on its own.
Authority being the scary word there.
Absolutely. The interface is shifting entirely from a conversation to a delegation.
So let us start with the immediate reality of what this looks like on your own devices. If you are listening to this on a laptop, think about the permissions you grant your software. We have things like Claude Code and Claude Cowork securing permission to physically use a computer on macOS.
Yeah, they can open your files.
Right. Open files, run developer tools, and navigate the operating system autonomously. And OpenAI is pushing hard in the exact same direction. They are throwing immense resources into building a fully automated researcher.
And an autonomous intern.
Yes, an intern. With the ultimate goal being a complex, multi-agent research system. But look, I have to be honest here. Giving an AI agent unrestricted control of your computer feels a bit like handing the keys of a Ferrari to a teenager who has only ever played racing video games.
That is a brilliant analogy.
You know they understand the theory of driving, but you are still terrified they're going to drive straight into a brick wall.
It is a very fair analogy, and it highlights just how profound this technical shift is. We are moving away from passive chat models into active agentic frameworks.
Okay, break that down for me.
Well, in the past, the model only processed the specific text you fed into it. Now, the model generates its own context.
Right.
It searches your local files, runs its own code, sees if that code fails, and then rewrites it based on the error messages.
So it is correcting its own homework.
Exactly. The role of a software engineer is actively shifting away from writing every single line of code. It is becoming something much closer to a factory manager.
Overseeing an assembly line.
Spot on. An assembly line of self-improving AI workers. You set the constraints, you monitor the output, and you provide the feedback loop.
But giving an AI the authority to execute tasks means giving it a budget. And, well, human nature being what it is, developers have immediately turned that budget into a bizarre competition.
Oh yeah, the leaderboards.
Have you seen these internal leaderboards for token maxing?
I have, and it is wild.
For anyone listening who isn't deep in the weeds, a compute token is basically a fraction of a word or data point that the AI processes. And tech workers are actually competing to see who can spend the most compute tokens on these agents.
Yeah, you have single agents consuming 700 million tokens a week.
700 million. That is like reading the entire Harry Potter series hundreds of times over in a few days.
It is a staggering amount of data.
I look at this with a mix of amusement and genuine horror. Spending millions of tokens has somehow become a corporate status symbol. Since when did burning server power become a flex?
It is a fascinating behavioral shift, but it reveals a very critical misunderstanding of how these tools should actually be measured.
How so?
Well, token spend does not matter if the underlying tasks are not being completed. A model might use significantly fewer tokens, but get to the correct answer faster.
Which is obviously what you want.
Right, because it is ultimately much cheaper and more efficient. But people are treating token consumption as a direct proxy for productivity.
Like, oh, it is burning energy, so it must be working hard.
Exactly. They assume that if an agent is burning 700 million tokens, it simply must be doing a massive amount of valuable work.
But it is not.
Often it is not. The reality is that a poorly optimized agent can easily get stuck in an endless logic loop. It is constantly running failing code and burning tokens without producing anything of value.
Wow.
It is productivity theater on a massive scale.
And that endless loop of failing code is exactly why we desperately need an intelligence reality check. Because before we hand over the Ferrari keys and let these agents burn 700 million tokens on our laptops, we need to know if they are actually smart enough to be trusted.
Yes, and the evaluation data is very telling.
The data in our notes here is just wild. There is a benchmark test called ARC-AGI-3.
Yeah, the ARC benchmark.
It is designed to evaluate agentic intelligence on highly interactive visual environments. It is basically a test of pure adaptability.
Right, how well it handles something entirely new.
And the statistics are shocking. Every single cutting-edge frontier AI model solves under 1% of these tasks on their first try.
Under 1%.
Okay, mate, I have to stop and push back on the logic here. If these frontier models fail 99% of the time on a basic test of adaptability, why on earth are multi-billion-dollar companies so eager to let them run autonomous code on their servers?
I know.
It makes zero logical sense.
It definitely seems contradictory until you separate raw capability from what the industry calls the monetizable spread.
The monetizable spread. Okay, unpack that.
So the ARC AGI-3 benchmark is specifically designed to test how a system handles a completely novel environment upon seeing it for the very first time.
Right.
Humans can solve nearly 100% of these environments on first contact because we have an innate understanding of physics and logic.
Common sense.
Exactly. AI struggles immensely with that kind of broad generalization. However, enterprise companies are not paying for an AI to solve abstract, novel puzzles.
No, they want it to do spreadsheets.
Right. They are paying for highly specific, deeply repetitive capabilities. The monetizable spread is the exact subset of a capability that a company will pay a premium for.
Ah, okay, I track with this.
You do not need artificial general intelligence to find a syntax bug in a specific block of code or to aggregate a week of meeting transcripts into a summary.
Right, so they were incredibly good at the boring, repetitive stuff,
Yes,
but terrible at the highly adaptive, unexpected stuff.
correct.
But even for the boring stuff, if they're left alone for too long, they tend to go off the rails, they hallucinate facts, or get completely confused by their own output.
Exactly, and that is why companies are not just deploying raw standalone models anymore. They're deploying incredibly complex harness designs.
The harness designs.
Yeah, think of it as setting up a courtroom inside the software.
Okay.
Anthropic, for instance, has developed a multi-agent architecture inspired by generative adversarial networks. That word adversarial is the secret sauce here.
Because they are fighting.
Yes. They split the task between three distinct agents: a planner, a generator, and an evaluator.
So they're literally fighting it out to get to the truth. It is like setting up a miniature corporate bureaucracy inside your laptop.
That's precisely what it is. The planner agent breaks down the complex goal into manageable steps.
Like project management.
Exactly. The generator agent actually writes the code or
Yeah.
performs the action. But then, crucially, you have the evaluator agent.
And what does the evaluator do?
Its entire job is to attack and check the generator's work against the planner's original specifications.
Oh, wow. So it just critiques it constantly.
Yes. By separating these roles and forcing them to debate, they force the AI to maintain strict coherence over long-running tasks.
That is clever.
It is. But even with these adversarial harnesses keeping the AI honest, the sheer volume of output is becoming completely unmanageable for human operators.
Well, and the METR tabletop exercise proved this perfectly. Researchers ran a simulation to see what happens when humans actually try to use these autonomous agents in the real world.
And the results are overwhelming.
Yeah, they found that AI-augmented workflows are becoming mandatory just to evaluate other AI models. The agents produce so much data, so many rapid experiments, and so much code that a human being physically cannot read it all.
It is impossible.
You literally need an AI to read the output of your AI. It is turtles all the way down.
And that runaway generation of data is exactly what is driving the most pressing physical problem in the entire tech industry.
The hardware.
Yes. All of these complex harnesses, the millions of tokens, the multi-agent evaluations, they require an absolute mountain of physical compute.
Which means pushing the global power grid to its absolute breaking point. The scale of the physical infrastructure being built to sustain this is genuinely hard to wrap your head around.
It is massive.
Elon Musk has announced the TerraFab project. This is a $20 billion joint venture aiming to generate 1 terawatt of computing power just to manufacture chips.
1 terawatt.
1 terawatt. That is roughly the total electricity consumption of several medium-sized countries combined.
It is hard to even conceptualize.
And I have to exhibit some genuine skepticism here. When someone who previously promised us a functioning Hyperloop says they are going to build a 1 terawatt chip facility, you have to take it with a massive grain of salt.
That is fair.
But whether it happens or not, it shows the sheer panic in the industry over securing raw compute. OpenAI is facing the exact same pressure.
Absolutely.
Wall Street is starting to express serious concerns about OpenAI's massive data center spending. The market is getting jittery about these endless capital expenditures on physical hardware.
The concern from Wall Street is entirely valid because the trajectory of cloud compute is physically and financially unsustainable.
It has to hit a ceiling.
Exactly. You cannot just keep building terawatt facilities indefinitely without eventually running out of land, water for cooling, and electricity.
Right.
And that is why we are seeing a parallel race moving in the complete opposite direction. Local compression.
Local compression.
Yeah. While some companies are trying to build massive data centers, others are desperately trying to shrink the models so they do not need the data center at all.
It is the ultimate contradiction. It is like trying to build a nuclear power plant to charge a smartphone while simultaneously trying to invent a smartphone that runs on a single potato battery.
That is exactly what is happening.
And the potato battery approach is actually showing some incredible results. Google has released the turbo-quant compression algorithm.
Which is a huge technical leap.
Yeah, it reduces memory usage by 6 times and boosts processing speed by 8 times without losing any noticeable quality.
It is incredibly efficient.
And because of breakthroughs like this, we are seeing developers achieve the astonishing feat of running a 400 billion parameter mixture of experts model locally on an iPhone.
On edge devices, yeah.
Before we get into the physical how, what exactly is a mixture of experts model? Because that sounds like I've got a tiny university faculty living inside my phone.
That is actually a perfect way to picture it.
Oh, really?
Yeah. In older models, the entire massive neural network activated for every single prompt.
Which I imagine drains massive amounts of power.
Yes, horribly inefficient.
Yeah.
A mixture of experts model uses a router.
Okay.
When you ask a question, the router decides which specific, smaller submodels or the experts are best equipped to handle it.
So it delegates.
Exactly.
Mm.
So you are only waking up a fraction of the brain at any given time.
That makes total sense.
But getting a 400 billion parameter model onto a phone comes down to a technique called quantization.
Right, quantization.
If you look under the hood of an AI model, it is essentially billions of mathematical weights. Traditionally, these weights are stored as 16-bit floating point numbers.
Which take up a huge amount of memory.
Right, because they calculate decimals to an extreme degree of precision. Quantization is the process of compressing those numbers down to 8-bit or even 4-bit representations.
Let me make sure I'm tracking this. So you are basically rounding the numbers off and dropping the extreme decimals.
Yes, essentially.
Yeah. But how does dropping half the data not completely destroy the AI's intelligence? I mean, it is like speed reading a novel, right? If you are skimming, you do not need to read every single grammatical article or perfectly punctuate every sentence to perfectly understand the overall plot.
That is a brilliant way to explain it.
Because the AI's reasoning is based on the broad relationships between concepts, so dropping that extreme decimal precision does not actually ruin the gist of the answer.
Exactly. Moving from 16-bit to 8-bit carries almost no quality penalty for the model's actual reasoning capabilities.
But it drastically reduces the memory footprint.
Right. And Google's turboquant takes this even further by reducing the size of the key value cache, which is the memory the model uses to keep track of the conversation context.
Oh, okay.
By compressing both the model and the context cache, you can stream a massive model directly from the solid-state drive of a local device.
Bypassing the cloud entirely.
Yes. Running compressed models locally on edge devices is not just a neat trick. It is the only viable way to escape the cloud compute bottleneck.
And escaping that bottleneck is critical because securing the talent to build those compression algorithms or buying the land to build those terawatt power plants requires astronomical amounts of money.
Staggering amounts of capital.
And when you start throwing hundreds of billions of dollars around, these tech companies instantly transform into massive financial and geopolitical chess pieces.
They absolutely do.
The numbers we are seeing in these memos are staggering. OpenAI is raising its valuation to $120 billion. They are doubling their workforce to 8,000 employees. And to secure the capital they need to build these data centers, They are offering private equity firms a guaranteed 17.5% return.
Which is incredibly unusual.
I have to jump in here because that does not sound like venture capital to me. That sounds like high-yield debt.
Yes.
Because apparently offering a guaranteed 17.5% return is just casual pocket change when you need to buy all the GPUs on planet Earth.
You are absolutely right to call that out. That financial structure behaves much more like high-yield debt than traditional venture capital equity.
Yeah.
It speaks to the enormous capital requirements of training frontier models. Most of that spending does not even go toward the final product.
Where does it go?
It goes toward exploration, synthetic data generation, and failed experiments before the final model is even trained.
So the financial pressure to deliver is just immense.
Immense.
Right. And while OpenAI is raising capital through private equity, Anthropic is weighing a $60 billion initial public offering. But Anthropic is also locked in a massive legal battle that really highlights the geopolitical stakes here.
The Department of War injunction.
Yes, they want a preliminary injunction against a Department of War ban. The government tried to label Anthropic a supply chain risk after the company explicitly refused to grant the Pentagon unfettered access to its models.
Right.
Anthropic stated they did not want their technology used for fully autonomous weapons or domestic mass surveillance. And the judge in the case actually cited potential First Amendment retaliation.
Which sets a massive legal precedent.
It really does. The judge basically said that code is a form of speech, and the government cannot brand an American company a saboteur just for expressing disagreement with military policy.
If we step back and look at the bigger picture impartially, it is a very clear observation of the global stakes involved.
Absolutely.
The race for compute and talent has transformed these foundation labs from simple software startups into critical national security assets.
Because the governments know what is at stake.
Governments are acutely aware of the economic and military power these autonomous models hold, and they are moving aggressively to control them. The tension between corporate ethics and national security is only going to intensify as these agents become more capable.
And we are seeing that aggressive control play out internationally as well. It is not just the U.S. playing aggressive defense. Over in China, the founders of an AI company called Menace have been detained by authorities right after selling their company to Meta for $2.5 billion.
Right, the Meta buyout.
The reporting suggests authorities are deeply concerned about domestic engineers and proprietary technology relocating to Singapore and being absorbed by an American tech giant without vetting. Meanwhile, in the West, you have an NVIDIA-backed startup called Reflection seeking a $25 billion valuation. Investors are literally calling them the open-source DeepSeek of the West.
Yes.
Deliberately positioning a corporate entity as a direct geopolitical counterweight to Chinese open-source models.
The technology has simply become inseparable from national security.
Yeah.
When you have software that can autonomously write its own code, conduct advanced research, and manage critical infrastructure, the country that controls the most efficient models and the cheapest compute holds a massive economic advantage.
Which explains the detentions and the massive valuation.
Exactly. The detention of the Menace founders and the framing of Reflection as a Western alternative highlight just how fiercely nations are guarding their AI supply chains.
Yeah.
It is no longer just a tech race. It is an arms race for digital talent and raw mathematical power.
It is a phenomenal amount to wrap your head around. We started with the software agent, clicking around your desktop and racking up compute tokens. And we ended up with terawatt power grids, 17.5% debt yields, and global superpowers wrestling for control of the underlying mathematics. Pulling all of this apart has been absolutely brilliant.
It is a wild time in the industry.
It really is. If you are listening to this on your commute or sitting at your desk, just look at the device in your hand and realize the sheer scale of the invisible war happening inside it. As the vocal technologist, I love tracking exactly where the code meets the real world, and this transition to autonomous agents is the most significant shift we have seen in decades.
Absolutely.
If we are already seeing developers burn 700 million tokens a week on autonomous agents, what happens to the global economy when these AI workers start managing each other without any human supervision at all? Keep that in the back of your mind if you watch all this unfold. I am your vocal technologist. Catch you next time.
Spoken Tech for your ears.